Petr Tsatsin is a AI consultant at SkillJump, and also Peter is leading data science team at mobile tech company. Before diving into your journey, Peter, we have a Quickfire ideal prepared for you.
Yeah, just a little sneak preview to come. So the challenge with this one, Peter, is that try to answer maybe one word or one sentence. And obviously we'll dive into these things more as we go along. First one, only large companies can take advantage of AI and machine learning advances from 2023.
I don't think so.
ChatGPT is the only game in town.
No, there are a bunch of things that people can use.
Okay. Companies that want to take advantage of AI need to train their own models.
Not true at all.
Lovely. And last one, true or false? Generative AI is useful, but it is a fad and it's overhyped. This one you might need more than that.
More than true and false. Definitely. Generative AI is useful, but I don't think it's fad. No, I think it's real.
Awesome. Great. With that, sort of laying the groundwork as we go in and talk about this, we talk about your background. Why don't you just give us a lay of land? How do you see AI in 2023? How do you think companies or individuals wanting to get into it, how do you think they should segment? Obviously, we talked about generative AI, we talked about ChatGPT, touched on those, but they're part of the overall space that is AI and machine learning. I'm sure everybody would love to hear more from Peter to see how you see it.
Yeah, definitely. So I think AI, it's been overhyped, the term itself. So, and people are still trying to define it. And to me, AI, people are just overusing it a lot. And sometimes they just call machine learning AI. They call, I don't know, advanced analytics also AI, and which is sort of true. But we need to kind of like think about like AI is just a huge space, which includes machine learning, deep learning, generative AI, all of that stuff. So I think most of the people, how they perceive that, they perceive AI as something more cutting edge. When people right now are talking about AI, they just talking about generative AI usually. So when I entered the AI community 10 years ago, people were talking about AI and then it means deep learning. So the definition kind of changing. But I think for me, AI is pretty broad, so it includes a lot of different things.
For people who are not really aware, what's the difference between machine learning and generative AI? People will still have confusion.
Yeah, machine learning is much broader, and it's been around a long time ago. Deep learning is just a specific tool set or methods that are within machine learning. And deep learning, why it's called deep? Because usually deep learning involves neural networks with several layers. Deep convolutional neural networks, where this is where the term is actually originated. Deep learning is a part of machine learning. So you can solve the problems using deep learning, or you can solve the problems using linear regression, and linear regression is machine learning as well. This broader term, data science, is in my opinion, encompasses the machine learning as well, because data science, it's using the data and apply the machine learning or deep learning methods to get insights from it. Also, everything that leads to machine learning problem formulation, right? So you have a business problem, you need to basically think how you solve it, whether you want to use some machine learning methods. Do you have a data? And data science basically does all of it. So just end to end, and then delivering the insights to and communicating with the business on the other side. How do we actually use it productively? So that's a data science, and it's much broader umbrella. Machine learning is more kind of technical term, so which encompasses all the specific methods that are being used. Linear regression, tree methods, deep learning methods. And then generative AI, it's a special class of deep learning. So where you're actually using large language models. And why it's generative? Because you're generating stuff. You're generating the text. So with this specific class of the models, and we can go deeper in there. It's usually this specific class of the models, large language models. They usually train differently, and they use transformer architecture. People, it depends on who you talk to. So if you talk to some experts, right, they would just have GenAI, and it means the specific class of types of the deep learning models that are used to build this, and methodology that used to build and fine-tune these large language models.
What do you think people can start discover by themselves? How can they implement the AI, or what they should learn in order to implement?
What businesses, some businesses are they're feeling pressure. Everybody talking about this new thing like generative AI, and it can do wonders. The talent in this specific area, the people who can turn some kind of LLM or this advanced technology into something that is going to provide the insights for and solve exact business problem that you are looking to solve for, is still scarce. And big companies, OpenAI and all the other things, they just hoarding these resources. So, and there is the huge scarcity. And you also have to have a very unique set of skills when you understand. Sometimes when you're talking to the businesses, they don't even understand, have a structure of all the business problems they have, and there's, we need to do this, but then you need to go and break it down into the maybe sub problems, and then find something that you can apply machine learning, or make sense to apply machine learning, not necessarily generative AI. For some businesses, right, you might not even need to apply the generative AI right now. You can just set up good analytics, and you will get the insights. So, and this is where also I think this gap is widening, because people, I'm gonna jump right through all the steps that I need to do into implementing some very cutting-edge technologies, right? But cutting-edge technology, generative AI, or even something deep learning models, it's a double-edged sword. So it can actually improve your outcomes significantly, but on the other side, you don't know about the failure modes of these models. If you implement some deep learning into the decision making on your, industrial line, so what is the failure modes? So does this system is actually robust to some kind of, if someone want to tinker with it, so, and you start making decisions that are not good, which is going to lead to stoppage of your industrial line. This is something that I think not all the businesses are thinking of or even aware of, so that it's powerful, but it also could lead to some significant issues if you're not doing it properly.
Peter, what would be evaluation, or how would, if this specific problem worthwhile to invest into implementing AI or not?
This is the hardest part of the whole business AI journey, because for that, you actually need to work on this interface, business AI problem. So you need to constantly work in this interface and say, okay, so let's try this problem. What do you guys want to do? Okay, so you want to do this. Then you go think about it and say, okay, so I don't think we can directly solve this problem, but we can reformulate it in a couple of others. And for this ones, we're going to build some machine learning models. But do you have a data? So that's another big question. Do you have a data, or can we set up the data pipeline so that we can gather the data to train whatever machine learning we want to train that corresponds to some valuable outcomes for your company? And you basically go back and forth with the business owners, and the technical staff on the other side, until you flesh out the something that is, you think that is going to have a potential to deliver the valuable outcomes. And my usual modus operandi, let's start simple. If you have nothing, let's see if you have a data that we can use, and we just basically apply some very simple proven methods, and we try to set up the whole pipeline, because ideally what we want, so there is another side. So the business, this is business AI interface formulation at the start, and then in the end, when you build the whole thing, right? So you deliver some insights from your AI system, whatever it is. So how do we measure the impact? And we cannot measure the impact by just using machine learning metrics. Accuracy of our model is 90% or 95%. It's so good. But how much of this machine learning metric converts into dollars, or do we actually solve the problem? What is the return on investment? How do we measure it? Right. So that's another part. So, and I think the companies who understands that they have to set up this whole pipeline from the very beginning, forget about what's inside, and forget about what kind of complexity of the AI models are in the middle. We can always make them complex. But we start from the simple thing. We build this pipeline, and then we start iterate. So basically changing the model, making it better, and see how the changes. Because, for example, if you want to spend, I don't know, another 2 months to getting from 95% accuracy to 99% accuracy, or whatever, IUC, whatever machine learning metric we're talking about. So how much it gonna give you in terms of dollars? So for big companies, Google, they know this they call this map. So how much if they improve the model by so much, this is gonna be that much of the ad dollars they're gonna regain. But for the businesses to kind of understand this whole pipeline and ecosystem, it sometimes takes time.
My takeaway is that the value, understanding and describing the value chain is really important. And then you have the how. You might have some AI, deep learning, whatever else in between. And you really want to understand the full value chain. You don't want to just implement something just for the heck of implementing it. It's not going to give you the results you want if you don't understand your value chain. You don't understand the benefits you can get.
Exactly. So that's spot on. So you also need to understand as I mentioned on the other side, the risks of the implementing AI solution, and the more complex the AI solution, the more risks, more rewards. So, and the risks are not only for the AI system not operating properly, but also in terms of how much time it's gonna take to implement something more advanced.
Understanding the problem, that would be the first step. The measurement of this problem would be probably the next step. And also, Peter, you mentioned, do you have data? Or is it organized data? Can you elaborate on that as well? What do you mean?
So about the data. If you don't have a data, you cannot actually train the model. But in the beginning, there was a question that, do you need to actually train your own model to get an AI? So I don't think so. So what you can do specifically with generative AI models, you can take off-the-shelf model and pretty much use a lot of different techniques, prompt engineering, for example, or prompt fine-tuning, when you basically give the big model prompts and the answers, and then you tell as the context, saying, hey, if you have this question, this is the answer. And you kind of fine-tuning it this way without basically touching the model weights or anything. So there is a lot of techniques available before you even touching anything. That's the beauty of the generative AI, that you can do so much with that right off the bat. But if you need something really specific for your model to work really good on the financial data, you probably want to build what they call foundational model. So Bloomberg GPT, for example, they took and they basically trained the model specifically on some financial data, so that it's domain specific. For the most of the use cases, for example, retrieval augmented generation.
So let's say you mentioned you're a business, you have a lot of documents. Let's say you have them in PDF. You want to take an off-the-shelf model and create a prototype where users or internal employees can query that data easily. So given the example, how does somebody start it to prototype? If you were a data scientist, or maybe even a junior data person in a company, and you were asked to prototype this, what would you recommend?
Yeah, so it really depends on the company policies. There is also, I think, GPT for the enterprise, and they added this retrieval augmentation capabilities actually. So my default answer here is just look at the ecosystem around, because there is emerging technologies and companies that basically try to specialize on some some facets of that. Once you looked around and you, let's say, oh, okay, so there is those options are here. So then, and let's say you want to build it. Most of the companies, they are really afraid right now about the security and privacy, because if you want to use something cloud hosted LLM where you would need to just send the request back and forth, and you kind of sharing the data with the cloud-based model. It raises a lot of security and company policy questions as well. Bigger companies are much more cagey about it, and they will, no, we don't want to do it because we don't really even know the implications.
I don't know if you read this article. It came out a couple of days ago where a lawyer got fired because he was using ChatGPT to generate his briefs and documentation. Well, I'll include a link in the description.
Mm-hmm.
And it just seems somebody didn't understand what language processing model ChatGPT, and basically there were references to things, to cases that didn't exist.
Yeah, that's called hallucination. It's called hallucination in
yeah. Can you talk a little bit about hallucination specifically and generally, just for everybody's knowledge? When you use some of these off the shelf models, they're based off a data set at a certain point in time. So talk to us a little bit about that. I think that might be useful for people to understand. It could be useful for me.
Yeah. So. Exactly. So I think I will reframe it a little bit. So I would just talk about hallucination as sort of a failure mode of the model, and there are a lot of failure modes that could lead to leakage of the privacy information and everything. People quickly realize that what if I just try to confuse the model? Can I construct some kind of image programmatically and feed it to the model so that it gives me some kind of answer, some positive answer? And you can imagine what kind of consequences it could have if your computer vision model sits in some kind of decisioning chain for your industrial pipeline, and somebody actually got access to that, and they can just send some programmatically generated image to confuse the model and made it to make some decisions that are not correct. So then it's a huge security risk. Same self-driving cars. What if somebody can actually tap into or mess around with the perception? And another part of the failure modes, for example, for self-driving industry is that you usually don't have a lot of images of the collisions. So you usually have a lot of images of normal situations. But the problem here is how the model is going to behave when there is going to be a very rare, possibly fatal situation on the road. And you can imagine if a lot of self-driving cars, they're going to generate, 60 frames per second. Each frame goes through the deep learning model, multiplied by how many people drive in the cars every day. Your precision when you're making a decision going left or right has to be pretty high, because you have, in reality, you're going to generate so much data that's going to flow through these models. And when you're training these models, you don't even have nearly enough examples that this model actually can generalize from. Not to scare people. I think current people about that is pretty aware of this. Just to give an example, going back to failure modes of the big generative models, it could start generating something that looks totally legit if you read it, and it will put even links or something to non-existent things. That's what called hallucinations. It starts hallucinating something that is not real, and that's a big problem.
So many pitfalls related to it. I wonder if we should switch gears and, sticking to 0 to 1 theme, talk about your journey, see what inspiration people can take from your journey if they want to go down the data science path.
Yeah, totally. One of the most interesting part, Peter, your journey. How did you?
How I end up? How you
ended up leading data science engineering team? Where did you start, and why you actually decided to move to data science machine learning domain?
I'm a physicist by training, and I actually moved to the United States to get my PhD in physics and computational astrophysics. I think it's a pretty unusual path when people in physics getting PhD, they usually end up into Silicon Valley. A lot of people in Silicon Valley, either they're just engineers or data scientists. A lot of people with the physics or biological or computational biology background, it's kind of a natural path, because I think it's the one of the most, to me it was interesting because I was doing the research. I know how to do the research in physics, and then I'm deep learning when I moved it to the Bay Area in 2014 and started working in AI company. Back then it was also kind of similar, right, to what I'm doing. So I was just reading the papers and trying to figure out what's going on and how to apply the AI actually to the real problems. So what I think stuck out for me and why I kind of get to where I am right now doing the consulting and building the teams and building the startups actually is because I always was interested. I think I figured out. So I always was more interested in applications, AI applications. That's why I spend a lot of time talking about bridging the gap between business problem and AI, which is really important. And for the applications, it kind of started driving me. I just want to beat some benchmark, or I'm interested in how to optimize the transformers so that they are running much faster than they are. I think I mostly started gravitating toward the applications. After I got into the space 2014, and right now it feels it's been so much progress in the industry. So I feel I've been in this space for 100 years because the progress is so fast. But when I started, there was no fall. So it was two types of GPUs on AWS that you can rent. So, and right now you have just basically NVIDIA's building the chips, which is optimized specifically for training large language models. So everyone, all the cloud providers, they just moved into, we just need to build a specific hardware for the stuff. And it's over the 10-year span. It's just crazy. After I worked for a while in this one AI company, and we built interesting AI and user experience for search, and we sold it as one of the biggest online shoe retailers. Actually, I actually moved into forming. I called it my own company, but I was a founding engineer. But I was there from the beginning till the end for 4 years. We were building automated machine learning platform exactly to solve this problems that we were talking about, bridging the gap between the business and the machine learning. So, however, I think this is where I mostly learned that there is you cannot just apply a set of machine learning algorithms blindly to some problem. You still need this human interface on the side where you have the business problem formulation and everything.
Peter, what would you recommend for those folks who want to get into AI career? Or where should they go to university to study PhD? Or you can learn on something on your own? What would be your advice for people who want to start learning or getting into?
Start learning, yes. Yeah, no, I don't think that you need a PhD at all. So to get in there, I think what's actually super great about the AI community, and I think it's been started by Andrew Ng, who basically founder of Coursera. And if you look at his current offerings, deep learning AI, they releasing the courses for free or for very inconsequential money. So if you really want to get into the AI, I would say there is plenty of the courses that you can just go and take. So yeah, I think it's probably going to be a problem on what courses to take. So my suggestion would be how to choose them. My suggestion would be just basically look at the Andrew Ng. It's going to give you a very very introductory stuff, so where you can use it and start moving forward. Another thing that I would say, just get into open source, because a lot of this large language models there and tools, they're open source. So, and once you get a little bit working with the past discourses, so you can just start trying all the different open source examples that are out there and try to contribute. And there's also Kaggle, the Kaggle competition. So basically where you can actually compete with people and try your skills. It's probably going to be quite hard and a lot of investment into that, but it's also interesting because then you can, if you just win some competitions, that's going to be just a much better mark on your resume.